So I will start, or my this presentation will be very simple enough, so that if you are able to, means if you are not knowing any special expert or advanced level, then only you can also grasp some fundamental concept and important aspect in this particular machine learning topic. So let me share my slide. So I hope that my slide is visible right now.
Yes, sir.
Okay. So this is a very simple topic, or a very interesting topic as well in the machine learning workshop and machine learning subject. So again, good afternoon to you all. Now hereby I will present or I will give the presentation or session on ensemble learning, and basically focus on voting based machine learning or ensemble learning models, and the Python and voting based technique, or using some case study or hands on. It will be covered by my scholar, Shri Rahul Mishra. So I will start this. Basically, if you are just wait. So when we are talking about ensemble learning, so we'll see that how many types can we have an ensemble of different machine learning models. So we are having a different type of machine learning ensemble model. So how they can be hybridized, or how they can be arranged, or how they can be composite in a manner to have good performance in a very special classification or regression or any other problem or pattern recognition task. So we'll have a different type of ensemble. So one is bagging. Here bagging method means it is a bootstrap aggregating basically, and second is boosting. So if you're talking about, it's a parallel approach. The first fundamental aspect of bagging, it's a parallel approach. And when we are talking about boosting, then the wrong classified samples are being given a higher weightage. It is basically a weightage boosting or weight boosting method, and which operates in a sequential. Different learner or base learners models are arranged in a sequential, so as to give the output generated by the previous one will take or feed by the next model, and whatever the misclassification done by previous model, they have been boosted, so as to special we can say the special attention for such samples will be assigned, so that the next they have been classified, or they have been given a higher weightage, so as to give a said that by the next step they will have a correct classification. And the stacking is basically the aggregation of bagging and boosting, or in a light sense we can say that it is a hybrid of bagging and boosting, where meta learners are being used. And either we used bagging methods, and then we can say that yes, the voting method by which we may, or the particular machine learning models, ensemble model may take the decisions, and either this particular classification task or regression task, either this particular sample belongs to one category or zero category, or yes category or no category, whatever. Okay, so these all will covered in a very simple sense. So here the ensemble model. Ensemble model means aggregation. We basically, what we face that we face the different errors or different problems, and while we are using the simple or isolated or single model. So number of times we have observed, I think you have already aware of the overfitting, underfitting issues, and so that maybe they are low performance, low accuracy, low sensitivity, and all those. So all those are there, means average performance or poor performance by single model. So basically, here we are having a different models. And all are aggregated so as to have giving a good performance. Okay, so this is the basic fundamental behind this particular ensemble model, that the different base learners are aggregated or ensembled and just to produce a single and more accurate and a classification, prediction, or performance of a model. So here are the core principle behind it, that wisdom of crowd. And just you have seen a real example of KBC. KBC. So whenever a particular participants wish to have a correct answer of the question asked by the organizers, so the crowd, the audience pool, audience pool. So they usually give their answer, and they based on their own wisdom they give the answers, and based on their majority voting, the correct answers is to be followed by the participant. And it reduces the variance bias and improve generalizations. So when the variance or bias is to be reduced, so we'll have a low overfitting issues. So works best on base models are diverse and independent. And basically here we see that a simple or similar models are discouraged. So we'll have a diverse model, then it may have a good feature extraction from the samples, and then it will work in a parallel manner or in a sequential manner. Then it will give the correct response or good response or good performance as well. So it is a foundation of different Kaggle competition solution we have observed. So now a more specific definition. So it is a method where multiple models are aggregated and instead of using just a single one, and each models are here we can call as a weak because in aggregation they are strong, but in isolation they are weak because they are giving a poor performance number of times. So combining their results gives a more accurate and reliable prediction. So multiple models together, they can improve the overall accuracy. They reduce the error by balancing mistake across the model. And the simple idea behind this is to combine opinion from the group. Just we have taken the example of KBC. And wisdom of crowd. So a single model may not be enough, capable enough to give decisions. So whenever we have a crowd or whenever we have a group of model, then we are just assuming that they collectively work and extract the significant features from the samples, and then they can give a correct response or good performance as compared to individual expert. Okay, so it's a collective knowledge and opinion of a group, and which are better at decision making, problem solving, and innovation than any individual. So this is the basic fundamental behind this ensemble learning. And here are the basic models is there. When we are talking about a training sample, we will have any number of sample data. So here we are just aggregation, bootstrap aggregation. So the number of the samples out of the total population or out of the total training data, these are the splitted into several groups, and this here different groups are allowed with their repetition and overlapping as well. Means it is not like that whichever sample we have taken for this group 1, it will be not taken by this. Repetition and replication is allowed here. So repeated data may be appearance. It means the random selection of, let us say that it is having a 900 sample, and here 300 samples are being here. So 300 samples, any samples randomly can be chosen for this group and for this model, as well as for 300 samples, again from this, and 300 sample from again from this. So the replication or repetition are allowed. Okay. And then this particular sample will be processed through a learner, base learner 1. This will be processed through a base learner 2. This will be processed through base learner 3. And based on they are capturing the important aspect of the data or basically the concept behind or whatever the features behind this particular sample data. They will classify the data as per their own features or as per their own capability, and they may give a yes, yes, or no based on their learning and training of the particular sample from their own model. So here we'll have a yes to out of three base learner, two yes are there. So based on the majority voting and or hard voting, the output will be yes. So this is a very simple concept of ensemble method. And so basically this is the example of bagging, and the first one. Okay, so let us take this hierarchy that what are the different ensemble learnings and based on which they have been classified. So we are talking about which type of data we are dealing with. Either we are dealing with a homogeneous data or a heterogeneous data. So for homogeneous data, we may use the bagging and or random forest. So these are the method of homogeneous data ensemble learning, bagging or random forest. Bagging, random forest is again also a simple model and based on the bagging. So again, the heterogeneous, when we are talking about heterogeneous data, then we will have parallel operation or sequential operation. For parallel operation, stacking is there. Where stacking means meta learners. And initially the base learners are there, 1, 2, 3 out of total sample, and the base learners are to be base learner will will be trained their model by using the splitted data as from their main population, and then they give rise to their own decisions or based on their own understanding and capturing the relation behind the different instances, and then they will process the data as a classification 0 to 1 or yes to no or any type of recognition task. So based on that, again, then after responding the each base learner, it will have a meta learner. A meta learner will be there, and meta learner will capture the important aspect as from the base learner 1, 2, or 3, and based on that, it will finally give the final output. So as to 0 or 1 or yes or no. So stacking, and in the stacking, we'll have a different boosting method. Either it is a ADA boost or XG boost or gradient boost. So we'll see on this particular later on. And second is sequencer. So sequential will be there. Sequential method, simple method, and it is a boosting. And a boosting maybe again ADA boost, XG boost, and extra gradient boost and gradient boost. So this is all about the hierarchy or tree of a ensemble learning based on the type of data, heterogeneous or homogeneous. So here again, we are just classifying all these ensemble model. So bagging. So bagging basically again, I am just telling that initially we'll have a list of data or a data set having any number of entities or any number of instances, and these are there. We will have a weak learner or base learner being used, and which run in a parallel. And independent subsets are provided from the data set. Let us say that it is a 250, and repetition and replication allowed, it is a 250, maybe like this. So for example, this will be all, and here 250 means it may contain a common data from this group as well, so from this model as well, and as from this other common and copied data may be there. So let us say that we will have a 800 sample out or 900 sample, and 900 out of 900 sample, we are just providing 750 sample here and 150 sample for testing. So later on, the testing will be there by these models. So based on this, yes, this yes, this no. So majority will be yes. So final decision will be like this. So bootstrap aggregating. So bagging method. And if we are talking about a boosting method, then it will be sequencer, XG boost or ADA boost. So basically from the total sample, 1 weak learner will be called, and all the data will be provided to this. Let us say that we will have 100 sample in a original in a data set, and out of 100 sample, all samples are being provided to this weak learner. And let us suppose that it is giving a correct response for 80 samples, and 20 samples are wrong response or wrong output is correct and wrong. And for this 20 samples, है ना, so error is generated for this 20 samples, and then for 20 samples the weights are boosted, and again for the 80 samples weights are decreased, and the weights are decreased. So ultimately, when we are giving a low weightage to correct samples, so more impact or more focused for this model, a weak learner model, or for upcoming weak learner model, will be for the wrong classified samples. So as we have seen that for 20 samples, so the next model weak learner will be more focused about these 20 samples, and it will again give, let us say that 80 plus 10, and again it is giving a 10 wrong responses. So again, for these 10 samples the weights are boosted, and the third weak learner third, so will be focused on for this more 10 sample again, and thereby let us say suppose that 1, 2, 3, and after 4 and after 5, let us say that we are getting a correct response for all samples. So by this way, the wrong samples, the weights are to be boosted because based on the error, and thereby finally having a correct response for all samples. So ADA boost or XGBoost are the examples. So we'll see the algorithm later on. And either we are using a bagging or boosting. So we will have combine the prediction as majority or average. So when we are talking about hard voting and soft voting, then example hard voting and soft voting. So in case of we are having a classification, so we may use the majority, and when we are taking the regression, we may take the average. So this is the example by voting mechanism. Okay. So and here is for stacking. So it is similar to this one, this parallel model, and here despite of this yes or no, it is all the outputs are to be hold, and the meta learner are to be called, and the meta learner will trace what are the important aspect which has been extracted by this model 1, model 2, or model 3, and based on that the expertise or the complex model or meta model meta learner will process the data and finally give the correct final response. Okay, so see, it is a same as a bagging. A stacking is based on the stacking parallel, and but the output will be hold till the meta learner is applied, and meta learner will finally give the response for final output. Okay, so this is all about the bagging, boosting, and stacking. So here the explanation part, as I already told, so there is no difference. So it trade independently on different random subset of the data, and finally the results are combined by for averaging regression and for voting classification, and it helps reduce the overfitting. Okay, so boosting is trained one after another. Each new model focuses on fixing the error made by the previous one, and final prediction is weighted combination of all models, which helps reduce the bias and improve accuracy. Stacking is basically a generalization, a stack generalization. Multiple different models of a different type are trained, and their predictions are used as input for final model, and this final model are a meta model or any expert model may be taken, and final outcome from there. So meta model learns how to best combine the prediction of the base model, aiming for better performance than any individual. While stacking is also method, but bagging and boosting method are widely used. So these two methods are popular, however, sometimes it is also giving the good results. But again, why stacking is discouraged? Because again, it totally depends upon the capability of meta learner or meta model. So again, the same things happen that individual may have good suitability for the data types, then it may give the correct response. Otherwise, it may again have a single method dependency. That's why it is not being a very popular method. Okay. So let us see that this bagging algorithm is step by step. So it can be used for both regression and classification. And the first step is bootstrap sampling. The data is divided into multiple subsets by the replacement and creating a diverse training data. And then separate model is trained on each subset individually, often in parallel for efficiency. Then prediction from all models are combined using majority voting or classification or averaging for regression. And then validation. It is OOB, out of bag, out of bag evaluation. That is, evaluation is a validation. Validation method for this bagging algorithm. So the sample, and I have already told that out of 900 samples, 750 samples have been assigned for training, and for assigning a different models, different 1, 2, and 3 model, and 150 samples have been used for here evaluation or testing. Samples that are not included in subset are used to evaluate a model performance without cross validation. And final prediction, combined output of all model give a more reliable and accurate performance. Okay. So this is all about a simple approach. You can explore the different bagging algorithms and more specific in your literature part as well. So here the illustration, different subset of training data, 1, 2, and 3, and any based learner or based models are there, and most frequent average prediction for regression, regression and majority voting for classification and final prediction. Okay. So here we are just taking the example of random forest. So random forest means it is based on the homogeneous type of data, and it is a group of many decisions tree. I think decision tree you have already aware of in your previous classes. So decision tree. So I think the decision tree concept of the concept of decision tree is well known to all of you. So just to recall that what are the decision tree here? The decision tree are basically are the pictorial representation and or any representation particular in a data structure format, in a tree format, and where the leaf nodes are the leaf nodes are the decisions, yes or no. So from the data or from the we can say that we will have a table of data and having different attributes, different attributes, and the final column of that yes and no, the final column of this. And here we'll have a sample 1, sample 2, whatever. And here in Y attribute 1, attribute 2, attribute 3, or so and so on. So the question is here that which attributes must be a root, or which attribute must be deciding can be considered as a root, and which one will be successor. So based on that, what is the principle behind it? The decision tree. The decision tree principle is there that we will have a information gain. The information gain. So whichever node or whichever attribute is having a higher information gain will become a root node. And later on the again for the rest of the data, again the attributes are to be evaluated for that maximum information gain. And maximum information gain, it is based on entropy, the degree of entropy. So again it will go on until the leaf node. The leaf node of the decision tree will be either yes or no, or true or false, whatever the situation will be there. So basically, so this type of individual decision tree are to be aggregated. So 1 decision tree, 2 decision tree, and 3 decision tree. Class A, it is a DC1, DC2, or a DT1, DT2, DT3, whatever. So maybe there. So out of the total sample data, homogeneous data, and the data chunk will be provided for this decision tree 1, and another data set, maybe repeated data may be there, a random selection. So again the data will be assigned for creating a decision tree 2, and similarly for 3 or 4, many more are there, and many more may be there. So out of this will decide that yes, for a class A, and for class A, let us say that we will have a final outcome 4. So it is giving a response A, it is giving a response A, it is giving a response B. So based on the voting majority, and the final output class will be A. So it will be like this, model. So model training, will perform out of data chunks or the partition of the data. The decision tree will be created, multiple decision tree will be created, and which will work on a parallel manner, and giving based on their own data, they will generate or decide the category of a particular sample. Either it is belongs to A or B or C or D. So based on their, the majority will be taken as a final outcome. So basically, this is there a very simple sense, random forest. So here, the same whatever I have explained, create a many decision tree and pick up the random features. Random features means here not only as we have already seen in decision tree. So each decision tree will have their sample and associated with the different features. So for this particular, when we are making a random forest, so not only we are picking the randomly the sample, but also picking the random features as well, which may have a good impact for making the decisions. And each tree makes a prediction here and combine the prediction and based on the majority voting or averaging for regression. So using this particular data and features, each tree helps avoid overfitting and makes overall prediction more accurate and trustworthy. So this is the concept of this particular random forest. Okay. Now the boosting is there. Second is boosting. So boosting is ensemble technique where multiple weak model are trained one after another, and each new model focuses on correcting the errors of the previous one and build a strong model. So the algorithm follows as, so initially all the weights are initialized. So we may take ADA boost example. So we will start, or training will start with the equal weightage for all training data. Okay. So then the weak learner are trained. First weak learner are trained with a simple model. And then since it is a sequential learning, so for this particular, when we are applied the entire data set for this weak learner, the weights are to be calculated. So weak learner weights are to be calculated by this formula alpha, that is equal to half ln natural logarithm 1 minus total error upon total error. So by this alpha will be calculated, and then weight adjustment will be there because weight calculation of weight and then weight adjustment. And weight adjustment will be the weight basically is a configuration of any network model, and for a particular specific sample the weight are converged so as to give a correct response. So this based on this error, the total error and weak learner weight, the classification are to be performed. Okay, and for classified samples, the weight will be updated by this term e minus power alpha, and for incorrectly classified it will be penalized by this term. So this is the error term, and here you see the error for incorrectly classified data or samples, the error will be penalized and the weight are to be increased for misclassified. So and at the last, when we will have a weights or random weight, and finally the weights are to be normalized in between or in the range of 1.0 or 0 to 1. And then again for this particular, we have just applied weak learner 1. So for all the again the updated weight, again this step will be again initiated from the step 2. Again the training this model, simple model, again calculating alpha, again we are checking the classification, either it is giving a correct response, either it is giving an incorrect response. And again for correct response, the weights are decreased, and for incorrect response the weights are increased because of the error. These weights are, this error term are to be product, and these are term are to be multiplied with the existing weight. So the penalized, and for incorrect classification, these term will be penalized and to be added. Okay, and normalization and final. So this sequence, sequence will be there, from this model, yes, a total sample, then weak learner, then weight updation, alpha calculation, weight updation product, and final weight updation. So again, then classification and classification, or sorry, normalization. Normalization, once we'll have a normalization, then we again repeat for next for taking a weak learner 2, and so on. Okay, so this is all about the boosting. Okay, just take the simple example. If I'm able to write this, let us say that you will have a data, instances 1, 2, 3, 4, 5, any feature, random feature. So we are taking a age, 25, 35, 40, 45, 55, and here illness, no illness, or yes, it is having an illness, yes, no, yes, illness. So this is the final one, so just taking a one feature, and the next feature will be either the person is ill or not. So based on this boosting, let us assigning an equal weightage of all. Let us say that we will have a 5 total samples. So for each sample, we'll have a equal weightage 1 by 5, 1 by 5, 1 by 5 means 0.2, 1 by 5, and 1 by 5. So here, how will calculate the total error? And let us suppose that a weak learner has responded correct response. Yes, it is a correct response. And here the output is given as no. And how here also output is given yes. It is also correct response. But here it is yes. Here it is no. So we are getting a 2 incorrect. 2 incorrect. Wrong output. And here again we are correcting yes, so it is also correct. So out of the 5 samples, we are getting a 2 incorrect response. So how we'll calculate the total error? The total error will be 1 by 5 plus 1 by 5. So total error equal to 2 by 5. So total error will be 2 by 5. So now as per our previous one, half alpha, alpha equal to half 1 ln 1 minus total error. Okay, so it will be alpha equal to half natural logarithm, 1 minus 2 by 5 divided by 2 by 5. So it is 1 by 5, 1 by 5. So it is equal to half ln 1.5. And it is 3 by 2. So it is roughly 0.2. Okay. So this is the outcome. A total error will be 0.2. So what will be the next step? Next step will be for classification. We will await adjustment. So for the correct response, for the correct response data, the weight will be updated. W new equal to W old into E for correct response, E minus alpha. So it is equal to, let us say that 1 by 5 into this, and E alpha, E minus 0.2. So whatever it is there, we can calculate. I have already calculated this. This will become a 0.16. So for corrected output, the new weight will be 0.16. So all this, it is correct. So 0.16, 0.16, it is incorrect, and 0.16. Okay, and for correct misclassified data or wrong data, wrong output, will have a W new equal to W old into E power alpha. So it is 1 by 5 into E 0.2. So it is, I have computed this value, it is 0.24. So for incorrect data, the weight will be 0.24. 0.24. So by this way, we have already observed that based on this algorithm, so the error term or for incorrectly classified samples, the weight are to be boosted. So for correctly classified, the new updated weight will be 0.16, and for incorrect classification, we'll have a 0.24 weight. So this is there. So by this way, again, the correct response will be checked. So with this data, again, training a sample will be again checked, and the alpha will be again calculated, and taking the response that again, let us suppose that a final outcome, again it is giving a correct response. So only one error, will be there. So 0.14, and for this error, again the alpha value will be calculated, and based on that, this is the error. The weight term will again be boosted, and for calling the weak learner 3, and again it will check and may give the correct response for all the samples, and thereby this algorithm will be completed. Okay, normalization will also there. So this is the illustration, simple, the out of total data set, base model prediction, and then taking the new weight updated, again the model will be there. New weight updated or configuration plus data set. This will be predicted weak learner 2. Again, with the weight, new configuration of weight and the data set, the final weak learner will be given the prediction. This may, and so on. Maybe 4, 5, 6, 7, or as per the data or as per the requirement. This will be go on till the correct response is achieved. Okay. So this is their boosting method, and in stack generalization, we have already seen that it is improved prediction performance, and here stacked multiple machine learning model combined together, just as what we can say bootstrap aggregating, bagging method. The same method means we'll have a multiple base learner from the total sample. So this may called as a label 0, and the outcome of this will be provided to a meta model or meta learner. It is a label 1. Okay, and then final outcome. So the main idea is different model learn different pattern from the data. This is the concept, and combining them increase overall accuracy and robustness. Stacking maybe a 2 level, level 0 as a base model or meta learner as a label. The base model first make the prediction independently, and then a meta learner use those predictions to generate a pattern. Simple. You can go through the specific structure generalization from the literature as well. So the same data same data set is provided to multiple models such as descent tree, random forest. So since stacking may use the heterogeneous data, so many model and many different varieties of model may be adopted. The random forest, support vector machine, or any CNN as well, VGG, any. So here, each model generates its own prediction, and these predictions are then used as a input feature for another model, and that is called a meta learner or expert model. And this study is output of all those models and learn how to combine them effectively for final outcome. Here you can see the illustration. We'll have a data set, different data set, means the data chunk. Out of we'll have a total sample or total population. Data is split into 3 parts with a repetition allowed, and then by applying this data set or splitted data to different models, and then meta learner. Meta learner is a expert learner or a complex model which trace the important pattern from this model, and or whatever the feature extracted from these base learners, and all are to be feeded by this metal number, and it will generate a final outcome. Okay, so this is the stacking model, and now the different varieties ragging and boosting. So we have already talked about a random forest, and it constructs the multiple decision tree, and based on the bootstrap subset on the data and aggregating their prediction for final outcome and reducing overfitting and variance. Okay, and random subspace method, it trains on random subset of input feature to enhance the diversity and improve the generalization while reducing the overfitting. So random subset, it is not a random forest, it is a for enhancing it models on random subset of the data to enhance diversity and improve generalization. And gradient boosting method, it is a boosting method, and basically it takes the gradient approach or boosting. And a gradient means derivation, or curve or a slope by which the particular error are to be the nature of error or the error are to be minimized with respect to change of weight. So these gradients are to be used for weight updation. So final weight updation will be there. So we'll have an error factor or weight factor. And this weight factor will be there. Let us say that we will have some alpha value and some hyperparameters may be there. So alpha, and this is, let us say that this is a error and with respect to change. So this error has to be minimized. This may be taken as a negative sign. Minus of alpha, partial differential of error with respect to partial differential with respect to change of weight. So this is basically to be extracted. So gradient boosting means this it takes the boosting from the gradient approach. And it is sequentially, as we have seen that boosting is a sequential approach, and it makes a decision tree, builds decision tree, and each tree correcting the errors of previous one and enhancing the prediction accuracy iteratively. Okay, iteratively till this iteration will go on till the final outcome as all correctly classified data. Extreme gradient boosting, it also uses the gradient, but it will also use the data pruning or alpha or beta cutoff in the tree structure or decision tree. Regularization method, it also uses the regularization method. L1 regularization, L2 regularization, and which is also a regression, and parallel process for robust and efficient predictive models. So the extreme gradient boosting means which also uses the concept to final for a alpha and beta cutoff or alpha and beta pruning, regularization, L1, L2 regularization, or some parallel processing for robust and efficient predictive models. AdaBoost we have already seen this challenge example by assigning weights to the data points, combining the weak classifiers with the weighted voting for final prediction. So weights, though, so incorrect classification are assigned a higher weight, so they have a good attention for the next weak learner model. CAD boost, another boosting technique, it is specialized in handling the categorical data or categorical features, and with extensive pre-processing. That means without extensive pre-processing, means the complete dependency on the particular weak learner model only. No pre-processing will be there. However, it will generate a high predictive accuracy with alternative overfitting issues handling. So now coming to this voting based method, and we have already seen that we have a type of ensemble. Either we are talking about a bagging method or boosting method or stacking method, and based on that we may use the voting based. And voting based may be used for classification and averaging for regression. So we are talking about the classification right now. So voting based is a machine learning technique where multiple models are combined to make a final prediction for voting based on the voting mechanism. So instead of relying single classifier, several models are together with improved accuracy and robustness. And final output is decided based on the majority of weighted votes of all the models. And these models are commonly used for classification problem, but different model can be captured different pattern from the data set. And finally, combining the overall prediction performance, which are more stronger and reliable. And so this will enhance the when we are combining. So the each weak learner comply each other, so that the particular data or particular aspect may be missed from one data, but it can be captured by another model. So overall, they are supplement to each other. And finally, based on their wisdom of crowd, they can give a correct response and higher performance ratio or higher performance achievement. So we'll have a two type of voting. One is hard voting and another is soft voting. So hard voting means 0 or 1 situation, and soft voting is based on probabilistic approach or probability. So we'll discuss next slide. So when we are talking about hard voting, the final class is selected based on the majority vote. Let us say that we will have a cancerous and normal data. So model 1, model 2 has given a 2 outcome as a cancer, and model 3 as a normal. So final prediction will be cancer. So like this is the hard voting. When we are talking about a mathematical representation, so majority of P1 or P2 or P3. So prediction from model 1, prediction from model 2, and P3 is a prediction from model 3. The final prediction will be majority P1, P2, P3. So here, let us say that P1 is a cancerous, so P1 will be a P1 equal to cancer. So it will be out. In soft voting, so here, probability of each class will be calculated. And based on our threshold, we may say that which one is having a cancer, or what is the probability of having a cancer. So this VGG16 model is giving the probability of having a cancer 0.92, less than 50 is 0.88, inception V3 is 0.7. So the average probability will be 0.83. So in soft voting, whether this 0.83 is significant value to say that yes, the sample may have a cancer or not. So it depends upon our application. So we may take some threshold value or some value or some deciding value. So when it exceeds this threshold, may have a cancer. Let us say that in general we are taking as a 0.5. So whatever the value of 0.5, exceeding 0.5, may have a cancer. Just roughly in rough sense we can say like that. So here, since it is coming a 0.83, so it may have a cancer. The final probability will be average of P1, P2, so soft voting. So here the illustration part. So we'll have a sample data. Again, the different models, classification models, random forest, extra tree, and here gradient boost, and then prediction 1, 2, 3, and based on the probabilistic approach, soft voting, and then ensemble prediction. So here for hard voting, here we can say that which one is showing the maximum mode, y1, y2, y3, which one are saying 1, or which model are saying 0. So whichever yes or no. So whichever is the maximum, the most votes wins. Okay. And here we are taking a probabilistic summation of probabilistic divided by the total number of possibilities. So model that output calibrated probability SVM LR neural net solution. So these are the suitable method, and here based on classification or binary classification, these are the suitable. So here training set, hard voting, same, yes, and total number of yes or no, and final whichever is greater, it will have a final outcome. Here which class means here we calculate yes value and no value, so based on that, if yes value are to be greater, so yes, the sample, applied sample may have a yes case, or if no case is higher, then we may say that yes, the no case, no means normal case will be there. That's it. So just for example, here model 1 SVM, model 2 model 1 dysentery SVM, Naip is, and we are just categorizing a cat, dog, and bird. So first one is categorize it as cat, second is dog as a cat. So we'll have two votes for cats. So panel will be a cat. है ना? And when we are talking about soft voting, so logistic model has given a P 0.7, है ना? Dog 0.3, SVM has given 0.4 probability for cat being a cat and for 0.6 for dog, and similarly neural network has 0.6 and 0.4. So we'll have a 0.567 to have that sample as a cat and 0.433 value as a probability and a probability value 0.433 as a dog. So which one is having a higher probability value? 0.567. So applied sample is belonging to category cat. Okay. So this is all about this particular hard voting and soft voting. The soft voting is generally preferred over hard voting because it provides a better prediction and stability and performance stability. So here again the same one, 95, 98, and so and so. So better performing models are again the next is this next is weighted voting. So weighted voting basically what is there? It is the method by which the expert model or the stronger model that are very suited for that particular data, and they are giving a higher weightage. They are giving a higher weightage. For example, model 1 has given accuracy 95%, model 2 has given 88%, model 3 has given 80%. Okay, so based as we have seen that it is a good model for the given sample or given data. So weighted voting scheme may be also applied. So this particular model is giving a weightage as a 0.5, and this model 2 as a, since it is a somewhat less value, so the weight of the outcome is given as a 0.3, and here model 3 is weaker as compared to first and second model, so it is assigned as a 0.2 weight. So 95.25 and 88 into 0.3, 80 into 0.2, so that the final outcome will be taking the average of all this. This one. So the better performing models are given a higher weightage. The concept is only that. And how to assign this validation accuracy, cross validation score, domain expertise, it is not. Okay. So comparison, yes, hard voting, soft voting, and input is class label, just theoretical part, probability and weight. Accuracy, moderate, higher, and highest. So these are the observations that which one is giving a higher accuracy or higher performance of a particular system or particular. So comparison of voting classifier as a voting regression. So when we are talking about a classifier and regression, then yes or no, cancer normal, benign and malignant. And these are the application part. Voting regressor is used for regression problem like house price prediction, temperature. For example, we are just taking that weather prediction. So today is very humidity, let us say that 90%, and the wind is having a 15 to 20 kilometer hour from the south, and there is a fog mist. So or temperature, let us say that is somewhat it is around 20 to 30 degrees Celsius. So what is the chances of rain? So it is the chances of rain, yes. So like this, so multiple criteria or multiple attributes, and based on those range, the prediction will be there. So temperature or weather forecasting, or the rain prediction and salary prediction as well, based on the experience, based on their age, seniority, and so salary prediction will be. So voting regressor example, a multiple regression model will predict a numerical value. Final prediction will be by a Bayesian value, like so. Just application for the voting regressor, stock, weather forecasting, sales, house price prediction, and so on. The classifier, it predicts category, class label, cancer normal, and regressor it numerical value. And as you know, I think the regression and classification the difference there, and the continuous value will be always a regression. One dependent variable and one is one or two independent variable. And based on one or two independent variables, the dependent variable may be calculated as a regression. So this is all about voting classifier for a classification task, voting it is for regression task, and both are powerful and ensemble learning. Okay. So these are the key points. Simple and fast majority soft voting sometimes it's accurate, but sometimes it takes time. Weight by model quality, most powerful. When to use, when the models are diverse, independent, and well calibrated, higher accuracy, robustness than any single method. So collective intelligence of the model, wisdom of cloud. So advantage, yes, overfitting improves and reduces overfitting, improves prediction stability, easy to implement, works with any combination model data, often boost accuracy. But what is their disadvantage? Increase inference time, higher model computational complexity, less interpretable than single model, performance gain limited if the models are similar. Same model अगर use करेंगे then there is no meaning of this particular ensemble. Soft voting requires probability calibration. The probability calibration or probability computation itself, it is a complex task. Okay, so these are the disadvantage. Improved generalization, all these robustness, noise, flexibility, bias variance trade-off, and their application part. Just go ahead. Real world application, medical, finance, NLP, vision, computation, recommendation. So one more, just simulator is there. I just wait. Is my screen visible?
Yes, sir.
So here, live simulator as the source, you just see this. And whenever we are just using a ensemble model, so based on this, the majority voting, I'm just taking as a simulation for majority voting. Let us suppose that we are taking about a logistic regression. Logistic regression is giving a let us say 60%. SVM is giving a 70%. Random forest is giving a 85%. However, KNN is giving a less 32%. So what will be the let us say that by hard voting what will be the outcome? So yes, so by hard voting, logistic regression class 1, SVM class 1, random forest class 1, however KNN no class 0. So by the majority voting we are taking as a class 1. So majority voting will be class 1 based on this weak learner or logistic regression SVM random forest, they are giving the response accordingly. So hard voting will be saying that yes, for ensembling of 4 model that the final outcome is class 1. And now let us suppose that we are taking a soft voting. Then soft voting will be confidence is 61.5. So for class 1 0.615 and for class 0 it's a 0.385. Okay, so again for soft voting the class 1 probability is 0.615. So we can say that yes, it is exceeding 0.5 value, so it may belong to class 1. And then weighted voting will be somewhat another. So again here you just say that yes, for the good classifier we are just giving the random forest as a good classifier, so we are just randomly we are giving a higher weightage to this classifier random forest. And then let us say that 0.5 and 0.4 and whatever, 0.1. So like so and so, 0.1 is there. So out of this four model, which one is giving a good performance, is giving a higher performance, higher weightage. So it is giving a ensemble prediction class 1 with confidence 68.2. However, for soft voting, it is not like that. It is soft voting means 61. So for weighted voting, the confidence score has been increased. So by this way, you can build the concept for the different voting mechanism, and either a majority voting and for hard voting, soft voting by probabilistic, and weighted will be the classifier to be assigned a weight value, and so it is a combination of hard and soft voting. So this is all about this particular classification ensemble model. So any doubt will be you can ask any doubt based on the this lecture. Else, my scholar will continue for Python coding for exploring the different ensemble methods. Yes, any doubt? Please, you can ask.
Participant, unmute yourself and ask question, or you can write question on chat box. Sir will answer.
Yes, sir. Good evening.
Yeah.
Sir, at the start of the ensemble learning, you talk about wisdom of crowd. What does it mean, sir, and how does it, we correlate this ensemble learning?
Wisdom of crowd here, actually, in a rough sense, we cannot say that he means the weak model can be capable for doing a classification very well. But the several weak learner may aggregate, and based on their outcome, based on their outcome majority, so the decision will be taken. So that is wisdom of crowd. Some are very intelligent, some are average, some are poor, or some are some medium value intelligent. So based on that, yes, we can say that the weak learner may give after aggregation, they give the correct response based on their voting skill. Okay. So technically, I'm saying that yes, for different classification tasks, so based on that, whether we are dealing with, in a simple sense, whether we are dealing with a simple problem, whether we are dealing a complex problem. Just take, for example, that linear separable problem. When we are talking about a linear separable problem, so it's a very simple classification method. A simple line or hyperplane can divide. So for linear classification, we may say that yes, SVM is a good. So SVM may give a good response. However, logistic regression may not be a good response in such cases. So and so. As per the model, we can say the beauty, or as per the model, what we can say, the features. What is the model there? In which part it is good, or which part it is very suitable, or which part it is not, or for such cases it is not suitable. So based on that, we are using the different models. So weak learner is not like that. We are just saying that it is a base learner or a weak learner. It is based on the data suitability, and it is a good practice to have that we can use the diverse type of base learner, not always a similar type of base learner. So when we are just using all those in aggregation or in an ensemble method, we can expect that we will have a good response or good performance of a ensemble model. Yes. Any more question?
No, sir. Okay. Thank you.
Okay. Rahul, are you there, beta? Hello, Rahul? Lila, have you contacted him?
जी सर कांटेक्ट करता हूँ.
हाँ. So he is the Rahul Mishra is also joining very soon. He's having some technical glitch at his end. So you can discuss some more aspect, है ना? Either any part of that machine learning, you can ask any question, है ना? I will try to respond. Okay.
Okay, sir. Just in this ensemble learning, so what I asked you is about the crowd, sir. Crowd means here you are talking about the different models output. Okay, na, sir?
Yeah, different. भाई एक मॉडल सफिशिएंट नहीं था, तो हमने 4 मॉडल लगाया, है ना?
हाँ.
हमने 4 मॉडल, अब 4 लोग मिलके किसी में दिमाग लगाएंगे. देखिए एक छोटा सा एग्जांपल, what example we are taking just as that if you are having a 4-5 per student, ठीक है, आपके पास 4-5 स्टूडेंट हैं, आपने क्या किया, सबको आपने एक क्वेश्चन पूल बनाया 10 क्वेश्चन का, और क्वेश्चन पूल बना के आपने अलग अलग कमरे बैठा के दे दिया. ठीक है, अलग अलग कमरे में बैठा के दे दिया. अब क्वेश्चन, वो पहला वाला जो बच्चा कुछ आंसर लेके आया, सेकंड वाला बच्चा कुछ आंसर लेके आया, थर्ड वाला, आपने कंपेयर किया, आपने सभी आंसर को कंपेयर किया, जिसका ज्यादा जो है सिमिलरिटी है जिसका आंसर, आपने उसको सही मान लिया. ठीक है, ये क्राउड है. मतलब क्राउड कहने का मतलब ये मैक्सिमम लोगों का अप्रोच ये है. ठीक है, कि ये डेटा इस कैटेगरी को बिलोंग करता है ना? सो दिस इज लाइक दिस द क्राउड. अब ये आपका सिंपल क्या है, आपका ये बैगिंग मेथड है. अब बूस्टिंग मेथड कैसा है? बूस्टिंग मेथड क्या है कि आपने एक बच्चे को बुलाया, सारा क्वेश्चन दिया, फिर दूसरे बच्चे को बुलाया, फिर अब देखा कि पहले बच्चे ने क्या किया है आपका, कि उसने आउट ऑफ 5 क्वेश्चन, है ना, he has attempted whole question but he has done a 2 mistake, है ना? Let us say that we are having a supervised nature of data, he has done a 2 mistake. ठीक है, नेक्स्ट वो उसको उस पर्टिकुलर को हाईलाइट कर दिया और बोला कि अब नाउ यू कैन फोकस ऑन दीज क्वेश्चन, ऑन दीज 2 क्वेश्चंस. The rest questions you can yes give the answer as well, but you need to focus on these 2 questions very much. Then second बच्चा आया, उसके लिए he has attempted and he has again done the great job, but unfortunately one question is still wrong. फिर थर्ड आपने बच्चे को लाया. तो this is about the, है ना, आपका boosting algorithm. So some sort of that. And what about the stacking? Stacking, it is like that कि we have again given the question pool or 10 question pool to different students group. They are attempting these questions in a separate manner, है ना? And we have collected the response of all the students. Now we have called expert or the topper of the student, है ना, in the topper. And now we have just assigned these, and these are the answer of different students. Now you attempt. Okay, so just what he will try that whether the student, the average student had done a good job or not, means a good calculation or not. So he will just try to capture what are the mistakes they have done, or what are the pattern they have just recognized, or they have just extracted from the pattern or from the data, and based on that he will give the final response. So this is all about the very simple sense that bagging, boosting, and your stacking. Okay, so wisdom of crowd means we are not relying on a single model, we are relying on a multiple model. भाई ठीक है, एक गलत कर सकता है, एक मॉडल गलत कर सकता है, 2 मॉडल गलत कर सकता है, लेकिन यहाँ पे 5 मॉडल है, 5 मॉडल गलत तो नहीं करेंगे, है ना? So this is like this. Yes, we are just increasing the complexity of the model, but still, if we are just concerned about the correct response, then there is no such, because the complexity of a particular algorithm or computation complexity, either in term of space or either in time of, doesn't matter at all, है ना? This may be a trade-off, okay, for giving a correct response or having a minimum error. Okay, so this is the way that we can have a wisdom.
Last question, sir. One last question. In this, here in stacking, we are adding the output of all the models and giving again modeling and again taking the output, sir. Okay, sir.
Giving we are taking the response of different weak learner or base learner, and not only giving the response of these learner to meta learner, we are also giving the solution of that, so that he can trace that by what he has trained this particular model has trained this particular sample, by which mechanism. Let us say that your neural network has trained the model by gradient descent approach. Your decision tree has they have taken. Yes, Rahul, just wait. Yeah.
Yes, sir.
they has taken the information gain approach and so on. है ना? So the meta learner is some sort of that expert learner, and it can trace that what the features have been extracted by this learner, and based on this particular, he again attempt those, and he will correlate the outcome of all the his own outcome, and then compare the result of this, and by comparing the response of other. So by this way, the extracted features are to be utilized by this meta learner as well, not only the response. Okay. Okay.
sir.
Thank you. Rahul, you can proceed, beta. है ना?
Uh, Good evening, sir. Yes, yes, sir. So, good evening to all the respected faculty members and dear participants. I'm audible to everyone. Is my voice audible to everyone?
Yes, sir. You are audible, sir.
Okay. Yeah, yeah. So let me just share my screen now, and continuing from the lecture session, uh, we are focusing on assemble learning model, and in the last examples we have seen that we have seen the example of hard voting, soft voting, weighted voting, and sir has explained various examples like cancer prediction and other examples. So we are also going through this practicals, and we will see in our Python notebook that how these are working. Actually, we are seeing that soft voting works better than hard voting. It is probabilistic way, but how practically it can be implemented, we will go through it. So let me just share my screen. Yeah, is my screen visible? Yeah. So this is a basic notebook in which we are just going through a data set in which we are just saying that whether patient is having a disease or not. And this is just a pulmonary disease. Like we have taken example of lung cancer, we have downloaded data set from Kaggle repository, and when we go through the data set, these are the fields. And as we, this is the first line, import pandas PD. We are just seeing this CSV file in which we are having age, gender, smoking, mental stress, exposure to pollution. And here in the last, we are just seeing here that whether a person is having a disease or not. It might be lung cancer, or it might be any lung abnormality. And by the help of various algorithms, we will see how individually they work. And by using assemble learning and what is waste method, which is already explored in the lecture session, we'll see how the results will be affected. So, going through the notebook, is the notebook visible to everyone? Hello? Is there no
Yes, sir.
notebook
Yes,
visible?
sir. Visible.
Yeah.
It is
Okay,
visible.
okay. Yeah. So, so this is just a basic program in which we are just selecting the target as pulmonary disease. It could be cancer or it could be normal. And I'm going through the notebook one by one, and I'm just running in it. And then in the next uh, cell here, we are using label encoder. Simply, we use to convert text into numerical values so that we can apply our machine learning algorithms. So it is just a basic, simple code in which we can find out that how all these voting methods could be utilized. Then in the next cell, again, we are using print test split function, and we are again the common approach in the machine learning that we are using standard scaler for feature scaling, and then we are fit and transforming training data and testing data. So one by one, I'm just running the cells. Then here it is the important part that we are using three algorithms. One is the logistic regression, another is the random forest, and last is the support vector machine. So these are the popular algorithms in machine learning. So we are using it, and by individual performance and by grouping it, we can see that how this work together and what are the results that we are getting. So we are creating the objects of each models. Then yeah, this is the important part in which we have covered in the lecture section. Here it is hard voting. Hard voting is very simple, as already explained here, that the majority of the models that give the voting that is preferred. So this is the simple approach in which we are creating a hard voting ensemble classifier, and we are using estimators, and we are using object LR, RF, and SVM for each and every model. And here the coding voting is equal to hard. So this will give us the result related to the hard voting. So we're running it, and we are importing voting classifier from sklearn.assemble. This is the library which is used for importing ensemble learning. So yeah, this is the diagram in which we are using three algorithms: logistic regression, random forest, and SVM, and we are using hard voting. And I've also used soft voting example also, same process, but here only difference is that we are using voting is equal to soft. So the same approach is used. Just we have to change voting from hard to soft. So we can find out that which model will be the best model. So here also three algorithms are used together. And then the next line, you can see we are predicting the test data set using hard voting model and using soft voting model. So I'm running the cell here. And then in machine learning algorithm, we calculate the accuracy score. So here in this cell, I've used both the accuracy and for comparison hard voting as well as the soft voting. So we will see and run the code, and we will find out that which will perform better. So it is a random data set. It depends data set, and we can see here, yeah, soft voting accuracy is just a little bit slightly higher than the hard voting classifier. So we can see the difference here, as we have seen in the lecture section also, that soft voting is generally preferred because it is a probability-based voting. And here in the practical example also, we are seeing that it is giving higher accuracy. Now, for exploring the data set, we are using confusion matrix that is regularly used in machine learning approaches. So here you can see a hard voting. We are using binary classifier 0 and 1, in which 0 represent normal cases and 1 represent the cancer cases. And here in medical imaging, main concern is the recall value. It is the positive cases that are actually uh, related to the cancer disease. So we can see almost the values same, but in case of soft voting, the accuracy is just slightly higher than the hard voting. And I said you earlier that it depends on data set also. In a small data set, you don't see large variation, but in big data set, in image processing, the difference can be much larger and higher. So you can explore by using this techniques. And then we are using the confusion matrix to find out that what are the results of the model related to soft voting and hard voting as well. So yeah, this is the confusion matrix for hard voting, in which it is saying healthy cases 522, and it is predicted healthy 49, but it is pulmonary disease. And here also it is pulmonary disease, and it is predicted 42, but it is healthy cases. And here the disease predicted is 387. And so in this way, you can say that this is the result of hard voting, in which we are getting result in which we can easily identify that what are the healthy cases and what are the uh, disease cases that has been predicted by the model. And you can see from the soft voting result. So yeah, the results is just almost similar like hard voting, because the data is small. But we can see slight difference that here the predicted value was 522 as the healthy cases. Here predicted value is 531. So it is increased. And here also pulmonary disease 386 it is coming, and there it is. So almost same results we are getting. So we have seen hard voting and soft voting, and the third is the weighted voting. In weighted voting, what we do is that we assign weights, and we think that which is the best model, we will give in higher weights, and accordingly we will get the result. So I have just used all weight combination. If it's, I don't know which model is performing the best. It might be possible that model 1 is performing better than model 2, or model 2 is performing better than model 3. So I don't know that what weight combinations could be the best combination for the model and the result. So here we are getting combinations from 1 to 3. It means that we are providing equal weight to all the model. Then we are providing higher weights to the third model, and so on. And the model used are the same model. Yeah, logistic regression, random forest, and SVM. Yeah. So let me just run this code. We will see in the result how it is working. Yeah. So in this, you can see that the weight assigned are equal weight to see all the models, and we are getting the accuracy 90.1.4. Then we are giving higher weight to the model 3. Yeah, the model 3 is SVM, so we are getting 91.2. And this in this we are just combining various values, and we are just running through the loop, and we are finding out what could be the best solution, because we don't know that by chance that which model will work on which data set. It is a trial and error base. So we can run through all the combinations, and we can find out that what can be the best combination for achieving higher accuracy. So it is still running, and you can see, we are getting higher accuracy, uh, 91.8, in which we are giving weight to model 1, weight 2 to model 2, and 1 to model 3. So 91.8 is the accuracy that has been achieved. Yeah. So these are all the results, and finally we just run this cell to find out what could be the best combination of all these combinations by using the weighted weighting. So yeah, this is the best combination. 2 comma 2 comma 1. It means we are getting giving uh, 2 for model 1, 2 for model 2, 1 for model 1, and we are getting the best accuracy as 91.8. So you can see from the result that weighted voting is also giving accuracy of almost 92%. But this is a very small data set, so you don't see various variation in the results. But in the whose data set or bulk amount of data set in GBs, it is different. And in all the practical approaches, it has been found out that the weighted voting is giving the highest accuracy, and hard voting is having low accuracy. Soft voting is generally preferred over hard voting. So this is the notebook, and it is very simple and easy logics that has been applied altogether. Yeah. So if any doubt, anybody, you can ask here. I think it is clear to everyone. Yeah. Okay. So running on, so continuing to this part, I have got one more notebook, and it is also related to hard voting, software voting, and weighted voting. Uh, Let me finish that, and then last we will just deal with the question and answers. So, this is image of three flower. This is a famous iris data set in which they are having three flowers, like Iris setosa, Iris versicolor, Iris virginia, in which we are having leaves. The bigger leaf is called sepal, and the small leaf called petal. And basically, in this classification, we have seen that it is having good results, because the classification is very easily identified between these three, that what could be setosa, what could be versicolor, and virginia. But if we just look at these two images very carefully, one is the versicolor and one is the Virginia, you can see the sepal of each flower is very similar, and it is very different to identify and differentiate between these two. So in another notebook, I will just use hard voting, soft voting, and weighted voting combination, because we cannot identify that which is the sepal of versicolor and Virginia, because these are very similar to each other, and so try to differentiate and find out that what could be the best approach. So I think the problem is clear to everyone. I will leave it Sotosa because it is can be differently identified. This seen the whole picture only, so it's very different from the two flowers. But to differentiate between versicolor and Virginia, it is quite difficult. So let's see that using the approaches of hard booting, soft booting, and weighted approach, what can could be the conclusion. So continuing to that part, yeah. So I'm running this simple notebook that is. The dataset has been taken from the Kaggle repository. Yeah. So in this notebook, we will see how we are differentiating between the IRIS dataset, and we will see how hard voting, soft voting, and voted voting could be used to differentiate between these flowers. Yeah. So I'm again running the code one by one. This is just a simple notebook. You can run from any Colab notebook. This very easy uh, program. So first of all, I am reading the CSV file that has been downloaded from Kaggle repository. Again, for displaying the dataset preview and checking the column head, I am using df.head. So you can see here is ID, sepal length centimeter, sepal width centimeter, petal length centimeter, petal width centimeter, and species are three species you can see from the here images also. One is Setosa, one is versicolor, and one is Vertical. And I have told you earlier that I will exclude this Setosa part because it can be easily differentiated between these two. And I will try the binary classification to find out how this works. Okay. Yeah. So again, continuing to the code. So in this, what I'm doing, I'm just removing the ID column. You can explore that if this is not used, or you can just remove so that we can, analysis the data in better way. So what I've done here, I've just removed the ID case, and the data set is almost similar from the previous one. Just have remove the ID column so that if it is not used, we can remove any column. Again, we are using label encoder to convert text label to numerical values so that we can perform machine learning algorithms in a efficient manner. So I'm running all those cells, and when I'm checking, yeah, so this is species becomes 0, 1, 2. So that we can apply the machine learning algorithms. Now, this is the important part. We are plotting pair plot so that we can find out that how every feature is related to the other features. So let me just run this code. Yeah. So you can see from here that here is sepal length centimeter, sepal width centimeter. These two are very overlapping from each other. This is correlated. It is very difficult to just differentiate these two features, the sepal length and sepal width. But other part, that is Sotosa, is clearly differentiating from the these two. So that's why from seeing the features and what I have found that to differentiate between those two classes is very difficult. So I just decided that we can do the voting method and we can find out that which could be the best model that can be implemented this. And I have just separated the third category, third class, so that uh, the the difficulty level can be improved. So in this pair plot, the pair plot is basically used to compare feature with every other feature. So what are the features are there? Petals, sepal length, centimeter, sepal width centimeter, petal length centimeter, and petal width centimeter. And from the diagram I've shown you, it is clear that petal is also could be differentiated very easily, but sepal length and sepal width, it is difficult to identify that which are these images. So my focus is this sepal only. Yeah. So continuing to this program. Yeah. So I am taking sepal length, sepal width, and species just because it is the toughest part, so that we can find out that how we can use voting assemble method to just find out which could be the best one. So these are the data set now, sepal length, sepal width species. So we are now having two species. What are the two species? Versicolor and Virginia. And I have just excluded that Sotosa part. Yeah, continuing to this code. So this is our new numbers of rows and columns. So we are selecting first two columns as our input features, and the last column is the target features. Again, we are using logistic regression, k nearest neighbor, random forest, and cross validation also. And these are the powerful machine learning algorithms that are used to find the results. So let's see how they work in this case to differentiate these images that are very similar to each other. We will see that. So we are making a list of machine learning model estimator in which logistic regression is represented by LR, random forest model represented RF, and k-nearest neighbor represented KNN. So these are the objects related to the models. And we are performing cross validation so that we can get best result. So running this code, yeah. So this is the result you can find. You can see that logistic regression is predicting the accuracy of 81%. Random forest is getting the accuracy of 71%, and nearest neighbor is having the accuracy of 76%. So these are the individual performance, and I just say to you that the results depend on data to data what we are using. Now again, the main part which is related to our lecture topic, the voting classifier. So again, we are using the voting classifier, and again we are using hard voting, soft voting, and weighted voting. So we will just see that if individually they are performing, and we are finding that the highest accuracy is 81%. So we are using hard voting, soft voting, and weighted voting. What could be the best result? Yeah. So hard voting has given the accuracy of 77%. And let's see what about soft voting. We will run and see. Okay. So almost same. They are getting the result. I already told you that the data side is so small that the results may vary. Yeah. And again, going through all the combinations, we will see that by using weighted voting model, what could be the best result. So yeah, you can see that if we're in model one, weight one, model two, weight one, model three, weight one, we are giving 76 accuracy. And already we have known that the highest accuracy is 81%. So let's see by weighted model, could we get the highest accuracy? Again, we can use multiple run and we can find out. Yeah. So I think that yeah, it's still running. I've just used all the combination of 111, 112, and so we can find out that what could be the best combination. Yeah, we are getting 80. Yeah, 80 is one of the results weighted voting, and I think that has been done. So yeah, you can see from here that by applying weighted voting, you got the highest accuracy of almost 80%. That was reported by logistic. So by trial and error basis, by experimenting, we can find out what could be the contribution of individual model, or it might possible by using soft voting or weighted voting, depending on the data set, we can find out that what could be the best result. Again, simple. We have created a sample data set here to find out the result of soft voting. Here, I am just using one normal classification in which I have created 1,000 samples. They're totally different from the previous code. This is just a test case that could be used to find out that what could be the best result if you are applying different techniques. So I am just having n samples of 1,000 features 20. This is just a random data set that I have generated by my side. And then I'm using SVM model with different polymorph degree, like polymorph degree 1, 2, 3, and I don't know what could be the best result. Yeah. And then I'm using SVM1, SVM2, almost SVM5 in which different polymorph degrees there. And I'm applying cross validation and I'm finding out that what could be the best result. So let me just run this code again. So we are using five SVM models with five polynomial degree, and these are the result: 85, 85, 89, 81, 86. And again, just to show how the voting works, you can use either soft and hard voting. So I'm using here soft voting, and let us see that by using predictive-based model, what could be the result. So it is running. So 93%. So here, this practical approach is clearly indicating that individual models, when we apply and we are using soft voting or weighted voting, we are getting higher accuracy. So, so this is from my side. Thank you so much to everyone. So, any question?
Participants, if you have any doubt, kindly unmute yourself and ask your questions. And you can else write on the chat box also. Sir, I think the participants got the clear view of the session. They don't have any doubts.
Okay. Okay. Any doubt? Anybody? Please let us know.
Participants, you can ask your queries if you have any.
Sir, please explain a little bit about hard voting and soft voting. How you are analyzing this hard voting? This is the zero and one based on this. Na? So, yes,
Hello. Yes. Sir. Can you repeat your question, sir?
sir.
Hello.
I am just asking. Yes, sir. I am just asking. So, how you are using hard voting? Like in hard voting, we are doing concept of yes and no only. Okay, sir. Means one or zero. So,
Yeah.
if the model is not correctly applying the means it will finally it may be that the answer may be wrong also if it is interpreting wrong. Please,
Sir, hard voting is hello. I'm audible.
yes, sir, yes, sir.
Uh, Basically, sir, if 5 to 6 persons are available and we have to vote, yeah, and five persons are saying that, like in KBC, you can see the example that we are having an audience poll. So yeah, so it is kind of that thing only that majority of people are intelligent people and already in the lecture part, yeah, we are saying the wisdom of crowd we are using, and that is very true. You know, if you just some prediction and you can see from the result the poll is coming out from the news channel. Yeah, so these are all we can consider. it is just a wisdom of crowd. You can see in the KBC also we are using audience polls. So maximum of the crowd are knowing the result. In that case, it is working, sir. And in case of soft voting, we are using probability that having higher chances and better result. And it is experimentally proven that in large data sets and complex data sets, soft voting has outperformed hard voting. Here in this case, we are using small data set, so not a lot of variation. And in weighted voting, we have seen that all the combinations can be applied, and we find out that what could be the best possible combination. Yeah.
Uh, Actually, you have rightly pointed the presentation there, है ना? Anil Sharma ji, are you asking question now?
Yes, sir. Yes, sir.
So the correct answer of this concern is that since you are asking that here again in the practical example or in Python in a code, the Rahul is showing just point value. I think that is a concern your concern. I think so. That despite of 0 or 1, he is showing point values there in hard voting as well. Is this your concern? Anil Sharma ji?
Yes, sir. We are not getting any.
He is not giving a 0 or 1 situation, rather than he is giving a point decimal value, even in fact, even in case of binary. So just imagine that we are using activation. Are you aware of the activation function? Whenever we apply any model, then activation function will be there. It will decide the last layer, and the last layer, before the last layer, we are having an activation function, and this activation function categorizes the 0 or 1 situation. Okay, so let us take the example of logistic regression, where we are using the activation function as a sigmoidal function. I think so you are aware of that. 1 upon 1 plus e minus 1 or e minus x. Okay, so basically the values are there. So somewhere we have to make a decision line. Okay, the hard voting and soft voting, I think there's concept from there. You just take the example of sigmoidal function. When the value of the particular outcome is exceeding 0.5, some curvature shape, from 0 to 1 snake shape curve is there. So whenever the outcome is exceeding 0.5 value, that category belongs to 1. Either it is, if it is less than 0.5 value, the category is 0. So based on that 0 and 1, the final outcome is 0 or 1. And that is taken as an outcome. Either the sample belongs to 1 category or 0 category. However, in case of probabilistic approach or soft voting, that decimal values are to be taken. Let us take that we are having a 0.2 value of class 0, 0.8 value of class 1. Now model 2 is giving 0.4 value of class 1 on 0 of 0.7. So individual these probabilistic or probability values are to be calculated. So there the model outcome is not to be considered. Here in hard voting scheme, either a model can give a 0 answer or a 0 category or 1 category. But here in probabilistic approach or in soft voting, they are not. They are giving the decimal approach. So the difference lies there. However, we are giving a decimal value in hard voting, but the category is 1 if it is exceeding 0.5 value. Got it, no? I think
Yes, sir, got it. But in soft voting also, the probability we are calculating here probability.
Yes.
How will take it? My concern is that how will take a probability function if it is more than 0.5, we'll take it a 1 in all probability also, right?
No. So their answer is simple. When we are taking a model 1, however, by applying activation function like a sigmoidal function, it may give the actual value by configuration or by finalizing the training, by finalizing out training outcome, the output is categorizing as 0.6 value. So 0.6 values are not to be taken in hard voting. it is by default, it takes the category 0 or 1. 0.61, it is category 1. And if it is 0.45, so by default, the model classify it as a 0 category. And that 0 or 1, final, when we are ensembling or making a cumulative decision, then the majority, which model is showing a 1 category or which model is showing 0 category, if out of 5, if we are getting a 3-1 category, then by default, that is to be there, that yes, the sample belongs to category 1. And however, in case of when we are doing a coding or in Python, then some accuracy or that and that, it is depend upon the total sample. Total sample. Let us suppose that out of 100 sample, how many we are having a correct response, or how many means true positive, and how much are false positive, how much is true negative, and how much is false negative. Based on that, accuracy is to be calculated. However, in case of soft voting basically calculates that how many, it forgets about the model, what the model is taking. So how many value we have taken or we have received for class 0. Class 0, let us say that the model 1 is giving a 0.2, model 2 is giving a 0.7, model 3 is giving a 0.4, model 5 is giving a 0.6. So this total column will be calculated. And similarly, for 1 category, the total column will be calculated. And based on that, the sample outcome is to be recorded. So that is there. And based on that the confusion matrix is to be plotted. So I think this doubt may be clear for this. So still you can have a doubt, then you can raise the concern. Our mail IDs are there. We can explain through the written comments as well. Okay. Thank you.
Participants, do you have any other question you can ask?
Okay, Vishakha. Vishakha, you can take the feedback, so that in next version we may improve the presentation, and
Sure.
We can show some real-time example, so
Yes.
many more sections presentation will come there, and hope for the best. And this is up to you. You can ask any time. The queries are there. Yes, and thank you very much for being a patient for attending this session. Thank you.
Thank you. Thank you, sir. Thank you for a valuable time and informative lecture. I truly appreciate the insight you have shared with us, which will be very helpful for our participants in future. Thank you, sir. Have a good day ahead.
Thank you.
Rahul Mishra, sir, session was extremely insightful.